For question 21, we're given two equations and we're required to identify the set of conditions for M, C, and A such that we have no points of intersection. So we're given a general equation for a straight line and a parabola with a dilation factor of A. So we're looking for when they have no points of intersection. There are several strategies to solve this. One way is to look at simultaneous equations. So that's the method I'll show you. So let's look at equating these two together. We know that if ax squared equals mx plus c, we know if this is true, then we have points of intersection, depending on the x values for which this is true. Well, let's try to solve for those x values. Let's put mx plus c on the other side of our equation, and we get a quadratic. We get a quadratic with a, m, and c as these quantities here and here. Now, if we want no points of intersection, this quadratic should have no solutions. If it has no solutions, then this equation has no solutions, and these two graphs won't intersect. And this is your Year 11 content coming back to haunt you once again, because the way we determine the solutions of a quadratic and whether it actually has any or not is with the discriminant, which says that delta b equals b squared minus 4ac, which is the bit under the square root in a quadratic formula. Well, let's substitute. B squared in this case is negative m squared, which becomes m squared. Then we have minus 4 times a times negative c, which gives m squared plus 4ac. Now, we should recall that if delta is greater than 0, we have two distinct solutions. If delta is equal to 0, we have one distinct solution. If delta is less than 0, we have no solutions. So we're really looking for the case where this quantity is negative. We want to know when m squared plus 4ac is less than 0. How are we going to do this? Let's look at each of these conditions here. Well, if a is greater than 0, if a is positive and c is positive, when we look here, this is the important bit. If a and c are positive, this quantity is positive. This quantity has to be positive, which means this is going to be greater than 0, which means we're going to have solutions, which means we'll have points of intersection. So that solution is not going to help us. Let's look here. Now we have a is greater than 0 and c is less than 0. Well, if a is greater than 0, if a is positive and c is negative, sure, this quantity could be negative. However, this condition doesn't state anything about m. So m could be arbitrarily large. It could be big enough to overweigh that term and give us one or two solutions. So that doesn't work. We have to involve m somehow. Let's look here, and this is where it gets a bit more nuanced. Let's try solving for c for this inequality, for this inequation. We have m squared plus 4ac is less than 0, which means that we have 4ac is less than negative m squared. Let's divide both sides by 4a. We have c is less than negative m squared on 4a. We have this condition here. C has to be less than negative m squared on 4a. But that doesn't make sense because here and here we have c is greater than that. So what's going on? I hope I've convinced you already that you can get rid of that answer. because if m is greater than 0 and c is greater than 0, then this m term can dominate and we'll get a positive solution. So it's one of these. Now, looking here, if a is greater than 0, if a is a positive quantity, then looking here we have c is less than negative m squared on some positive quantity. That's not going to work for us. We want c to be greater than this. We want this. Well, that's only going to be true if we can somehow flip the sign here. If we want to flip the inequality, we have to flip the sign. So the way we flip the sign is by restricting a. We can say, well, if a has to be negative, then we're allowed to flip the sign here. If we change the sign of one of our quantities, we can change the sign of our inequality. That means getting rid of this one, which means that D must be our answer. Let's look again. Why is D our answer? It's because if A is negative, you get negative m squared on a negative quantity, which is positive. That satisfies what we need here. And we also have A is less than 0. Well, that makes sense too, because we want this quantity here to be negative. And if A is negative, C is guaranteed to be positive, so that becomes a negative quantity. So try to unpack that argument on your own, and you should get the answer D.